So we are going to start with latitude by meridian altitude. So basically, we do celestial observation for getting position line and our position through celestial bodies when uh, at the sea we don't have any terrestrial objects. So latitude or by meridian altitude, so we get latitude when the body is on the meridian, that is on its maximum altitude that we will see meridian passage. So let's see. Meridian altitude can be defined as true altitude of a celestial body when it culminates. Culminates means it starts reducing the altitude when the body is on the observer's meridian, also called meridian passage. So on the observer's meridian. So this is the observer on the celestial sphere, and zenith is the projection of observer's projection on the celestial sphere, and this is north and southeast direction, and this is our rational horizon, and the body is passing through this when the moment the body passes on the observer's meridian, which is passing through the observer. So this is the observer's meridian, the yellow one. As the body passes through the observer's meridian, this will be the altitude of the body or the true altitude of the body at the meridian passage when it occurs. And this is the zenith distance or meridian zenith distance. That's from the body to the observer is zenith distance. And the bearing will be either the north or south. So you can see in this diagram also zenith nadir. This is the vertical circles, and this is rational horizon. On this rational horizon diagram, this is the past of the celestial body when it comes at the observer's meridian. This is the pole, and this is zenith or observer, and this is the equinoctial or equator projection of equator on the celestial sphere. Rational horizon yellow color and northeast southwest point. Now the celestial body is moving on its path, and when it comes to the meridian, that time we will take the meridian altitude. That is, altitude means the distance from the rational horizon to the body, and the distance between the body to the zenith is zenith distance, and it is on meridian, so it is meridian zenith distance. Now azimuth is either north or south in this only, depending on the declination of the body, and body is on this declination. So declination is the equivalent of latitude on the celestial sphere, and as the body is here, we can say that body will attain maximum altitude or maximum altitude, you can see in this case, or minimum zenith distance. So this is the zenith distance. So this is the minimum zenith distance the body will have at the meridian passage. So in this case, azimuth will be north or south from the position. So the position line will be east or west, 90 degree to the azimuth. And this will be passing through our latitude. So this is our latitude. So position line will be on the latitude of the observer. And this is the zenith distance. And this is the declination of the body. So if we know the declination of the body, we can easily observe, get the latitude of the body. So declination minus zenith distance is your latitude. So position line is east-west, and it will coincide with the parallel of latitude. And meridian zenith distance from celestial body is the distance from celestial body to the zenith, and the declination is celestial body we have seen here. So if we subtract declination of celestial body from the zenith distance, we'll get the latitude of the observer. And MZD, meridian zenith distance, always named opposite to the bearing of the CB. So if true altitude is north, then MZD is south. So we'll see that. So like example, meridian zenith distance 2030 and bearing of sun is north 000 degrees true. Declination of the sun is 5 degrees south. So if when you are given bearing also north or south, that then also you can find out that this is a sum for latitude by meridian altitude. So find the latitude of the observer. It, so when you need to find latitude, then also it is latitude by meridian altitude. So we mark declination 5 degrees south. We have the equinoctial, and bearing of the sun is 000. That means zenith distance is on the north. Zenith distance is 20 degree 30 minutes south. Bearing is north, so zenith distance is south. So this is named opposite to bearing. So south of the sun is your observer or zenith, 20 degrees 30 minutes of the observer, or so we can represent on the rational horizon north, south, east, west, and we have zenith. So body was here, body has come to the meridian. Declination of the body is 5 degrees south, and Q to Z is the latitude which we need to obtain, and body to body to this is your zenith distance xz, that is your 20 degrees 30 minutes south, always opposite to the bearing. You can see bearing means sun is north, so zenith distance is south. X to Z is always the zenith distance is from the body to the zenith. Next example is zenith distance 20 degrees 10 minutes. Bearing of sun is 180 degrees, that is south. Declination of sun is 10 degrees south. So let's draw this line, equinoctial, and declination of sun is 10 degrees south. That is from equinoctial, the sun is south. And bearing is 180. So MZD is towards north, means the body is north of the sun, because the bearing of sun is south, the body or observer is north. So zenith distance from body, sun bearing is south, so meridian distance is north of the sun, or observer is north of the sun. So on rational horizon diagram, we have equinoctial east, west, north, south, and declination we mark 10 degrees south. And from, since the sun is south, so from sun to the zenith is your 20 degrees 10 minutes north. So QZ is our latitude, 10 degrees 10 minutes north. So we get the latitude what was required.